Hi students, today class we are going to discuss about the topic name is called photoelectric transducer. From the name itself you can guess it what is meant by photoelectric transducer, right? So already we know what is meant by transducer. So transducer is a device which converts one form of energy into another form. Okay, so here we are considering what photoelectric. So from the name itself you can come into conclusion or guess that photo means it's nothing but it's a light photons, and electric means it's nothing but electrons, right? So here the transducer, which is mainly used to convert the light energy into electrical energy. Okay, so that is the main motto of this photoelectric transducer. Okay, so photoelectric transducer is transducer which convert light energy into electrical energy. So that's why the name is a name has been given as a photoelectric transducer. Okay, so let's see what are those. Okay, so for introduction, so photoelectric transducer, as I told you before, it always follows the principle of converting a light energy into electric energy. So because of this only, that name of the transducer is photoelectric transducer. Okay, so how it's getting converted into electrical energy, that is when there is a incident light which is falls on something, it's being converted into electrical light, right? So what is that process? In the sense, this type of transducer always contain photosensitive material. Okay, so it is always contain photosensitive material. This material which has a capacity or the potential to convert the photons, that is incident light, into electrons. Okay, so when the radiation, when the light radiation or any photons which when it falls on the surface of these photosensitive material, then it is in turn converted into electrons. These photosensitive material which start to emit the electrons in turn, which in turn you have when you have the incident of any light radiation. Okay, so this is the main element which is being added in transducer. So main element is what? It's a photosensitive material. So when there is a fall of any radiation on the surface of photosensitive material, these all light radiation which in turn get converted into equivalent electrons. Okay, so after these electrons will be either recorded or measured by using either galvanometer or some other voltmeter like that. Okay, so if you take the photoelectric cell, that is a photoelectric transducer, that is majorly classified into two types. One is photovoltaic cells, another one is photoemissive cells. So these are the things which is there in our syllabus also. First we will see photo emissive type. Okay, we have two types, right? First we will see the photoemissive type. So in this photoemissive type, again it is been classified into two types. One is phototube transducer, another one is PMT, that is photomultiplier tube. Okay, so these are the two things which come under the category of photoemissive type for photoelectric transducer. Okay, so these are things which is there in our syllabus also. First we will see what is the phototube. Okay, so the tube means it is in the form of tube structure. So inside you have two important things. One is anode and another one is cathode. Okay, these are two important things which is actually plays a very important role in order to convert light into electrons. Okay, so the cathode, right? So cathode is nothing but here it acts as a photosensitive material. Okay, so here it contains both cathode and anode. Here the cathode material is being coated with photosensitive material. So here this cathode only acts as a photosensitive element. Okay, and anode is similarly which is placed in parallel to the cathode. Okay, see this diagram, this is arc shaped. Okay, this arc shape, here they have given as a half cylinder shape, in the form of half cylinder. You know the cylinder shape will be like this, right? So if you cut this, you will have some off shape of arc shape, right? So that is the shape of what? Cathode. Okay, so here the cathode is in the form of half cylinder. Both the cathode and the anode which is placed inside the evacuated tube. So that is the tube, it doesn't contain any other gases. So it's called a evacuated tube. That is, and also airtighted tube. No air will let inside the chamber or the tube. So it is called evacuated tube, right? So both cathode and anode will place inside the evacuated tube. It is a closely tightened. Okay, so this arc shaped or half cylinder shaped one is the cathode, which is coated with photosensitive material, and the opposite to that you have a anode. Okay, so this is present all along the axis of the tube. Okay, so when the light is incident on this cathode, okay, when you are exposing this tube under any emission of light, when the light strike on this anode, since it is being coated with a photosensitive material, it starts to emit electrons. Okay, so because this material is being coated with a photosensitive, when the photons strike on that, the electron which is coated in that material will start to emit. So these emitted electrons or these generated electrons is further collected by anode. Okay, that's why you have the anode just opposite to the cathode. So whatever the electrons which is emitted from the photosensitive material, that is from the cathode, which is always being attracted towards the anode, or it also can we also can say like it can be collected by the anode. So now the anode has the collection of electrons, which in turn also called as anode current. Okay, these anode current further we can be measured by any means of device like galvanometer or voltmeter. Okay, so here the thing is, the current which is created between cathode and anode is it's nothing but is a measure of the radiation which is falling on the detectors, that is the amount of light which is strike on the cathode. Okay, so here in this way we are converting what electrons, that is sorry, photons in terms of electrons. Okay, so because the photons again we can't be processed by any other circuits, we have to convert into some readable form that is more accurate form, so that the subsequent or the forthcoming circuits can be processed easily, right? So if you want to process in any type of circuits, first we need to convert any type of energy into equivalent electrical energy, so that only it can be processed by circuits. So that is the reason we are using the transducer in this area. So transducer is a device which converts mostly the mechanical energy into the electrical energy, or we can also say the non-electrical parameter into the electrical parameter. Okay, so far we discussed like what is transducer, different types of transducer. We have come across so many types of transducer where we can convert the displacement, pressure, force, everything that is a non-electrical parameter into electrical energy. Similarly, how the optical radiation, that is the light, how can be converted into electrical energy? What type of transducer we can use it? That is the thing we have discussed here. Okay, so now we discussed like how the photon is being converted into electrical energy is nothing but by using photoelectric transducer. Okay, so this is the one type of device where you will convert the photons by means of some photosensitive material. Whenever the photons strike that material, it will start to emit the electron. These electron which is emitted from the sensitive material is further collected by the anode, that which in turn is called anode current. Okay, when you measure this anode current, this is directly proportional to what the light which is strike on the cathode. Okay, so this anode current, now what has happened, now the photons, that is the non-electrical parameter, it's being now converted into electrons, that is electrical parameters. That is the motto of this photo tube, right? So this is the another pictorial representation of photo tube working process. So as I told you, you have what a cathode, that is the arc shaped metal. This metal is usually made up of what photoemissive metal, or also called as photosensitive metal. Okay, and opposite to this you have what anode. Okay, that's why it carries a symbol plus, and a cathode carries a symbol minus. And these whole thing, anode and cathode, is always covered by one tube. That tube is made up of transparent material. It is very important. The material which is used for making the tube is another important factor to be considered. If you are making the material which is an opaque, means the light will not penetrate the tube and will strike. It will not strike the cathode, because the opaque means it will reflect all the light. Okay, so it will prevent the passing of light into the cathode. So it is always we have to be very focused that the material which is used for making the tube should be transparent, so that it will allow all the light to reach the photocathode to have the proper working operation or proper function. Okay, so tube which is made up of tube which is used to make the the sorry what the tube always should be made up of what? Transparent material. That is very very important. Then you have what? Incoming photons. It is the incident photons or incident light. So when these incident lights strike on cathode, as a result there is the emission of photons. These photons will be collected by the anode. Okay, so anode means now the anode will start to have what? Anode current. So that is the I. Okay, so when you want to measure the equivalent voltage means you have to apply Ohm's law, that is I is equal to V by R. So you need what? V. So V is equal to R by I. Okay, so now you have the current, that is anode current. If you have fixed any standard resistance means, then if you measure the voltage drop across this resistance, we can able to measure what is the equivalent voltage, right? So that is the thing we have done here. So you have the anode current now, but you need output in form of voltage. You don't want the output in forms of current. So now you want to convert this current into voltage means, then one more thing is needed, that is the standard resistance. When you fixed any standard resistance, and obviously when you measure the voltage drop, that is when there is a passage of current across the resistor, you will be having the voltage drop, right? So when you measure this voltage drop across the standard resistor, there you will get what is the equivalent voltage signal for that equivalent current, which in turn equivalent to what? Incoming photons. Okay, so incoming photons is equivalent to what? Your current, anode current. Okay, so the anode current now, which is being converted into what? Voltage by means of Ohm's law, that is the output. This is equal to what? Anode current. Okay, so incoming photons which in turn convert into anode current, that is the equivalent anode current. Again the equivalent anode current which in turn convert into equal voltage signal. In this way we are converting the photons into electrical energy. Okay, so here you have added an amplifier. What is the purpose of adding amplifier? In the sense, the voltage drop, that is the potential difference or voltage drop across the resistance, will be in a very small in range, that is in range of millivolt or something. So this signal is very weak signal. We can't be processed this signal in subsequent circuits. So in order to improve or strengthen the signal, we are using amplifier here, so that will amplify millivoltage will turns into voltage or something. Okay, so that is the reason we have added amplifier. Most of the transducer or the sensor, whatever it is, it used to give the output in terms of very weak signal. Okay, that is in range of very minute range, that is millivolt or a milliampere, like that. Okay, so this signal is not good enough to be processed by the forthcoming circuits. Okay, so that's why, that is the reason we have added amplifier. So after the amplifier after doing amplifier, if you see the output, you will have very strengthened signal. That is the voltage. That voltage will be equivalent to the incident of photons. Okay, this is the overall working principle of a photo tube. The one more important thing is we need a supply here. Okay, the photo tubes or photoelectric transducer or PMT tube, if you take anything, is all these all things are it's a type of passive transducer. We know already what is the passive transducer, right? So the passive transducer is the one which is require external supply for their operation, right? So here also, for to energize the cathode or anode, you need some external supply, so that only when on the striking of photons, it will be get converted into the electrons. Okay, so to energize that, we are supplying some power supply from outside. That is, here we have given a 90 voltage DC supply. Okay, so that is the purpose we have given. So since we have added this type of transducer is called passive transducer. Okay, students, that's all about today class. That is a photo tube. Next class we will see photo multiplier tube. Thank you.